So hello everybody, how are you all? I hope everybody is good and fine. So this is me and I welcome you here in this lecture. This is lecture number 7 of our chapter electricity. Let's begin this class without wasting our time. So what we are going to discuss today? We are going to discuss about the electric bulbs. Yet we have seen what is electricity, what is electric current, lots of things we already have seen. Now here we will be discussing about the applications of electricity. The application of electricity. So we also have seen electric iron. Electric iron. Now, this is another application, and that is electric bulb. So what happens? Basically, in bulb, we use this metal tungsten. What do we use? Tungsten. So this tungsten has very high melting point. Very high melting point. And what is the value of its melting point? So this is the value of its melting point. 3380 degrees centigrade. Okay, this is the melting point of tungsten. Now guys, we also ensure that the length of this wire, the length of the tungsten wire is high. The length of the tungsten wire is high. So this is your length. Let me erase and write it more efficiently here. It has higher length. Okay. Now guys, let's talk about the area. So basically, we all know that a resistance is inversely proportional to the area. So if we need the high resistance, then we have to take area smaller. So what we do, basically we can write that the area is smaller. Okay guys, so I hope you get my point that in this case the area is smaller. Now let's talk about resistivity. Let's talk about what? Resistivity. So this is resistivity. Let me write it here. Resistivity. And here in this case the resistivity will also be higher. Okay, basically what we want to do, we want to increase the resistance. Okay, so that if the resistance is higher, then in the smaller current the heat effect will also be higher, because we know that heating effect can be written by this formula I square IT. This can be written by this formula I square IT, where this heating effect is directly proportional to the resistance. So we need high heat energy. So to increase heat energy, we have to increase a resistance. So these properties of this tungsten wire will make its resistance very high. And that is so useful for us, because what happens in electric bulb, when you pass current across this tungsten wire, then the heating effect will be higher, and because of this heating effect, a tungsten will, you can say a bulb will start to glow. Okay, if a tungsten will heat up, then a bulb will start to glow. So I hope guys you get this phenomena, or you get this mechanism of bulb. Now let's move on to the next slide, and before moving ahead, let me tell you one other point also, and that is in a bulb, we actually fill this bulb with this argon. Okay. Now, you might ask me that why do we fill only argon? Because there is lots of gases. Why can't we fill those gases? So the answer here is basically argon is an inactive gas. Inactive gas is it doesn't react with anything easily. So to prevent this from the outside oxygen, what do? We fill it with argon so that this tungsten cannot react with oxygen from outside. So I hope guys you might get this point. Now let's move ahead to the next slide and let's talk about electric fuse. Electric fuse. So this is the image of an electric fuse. This is an image of electric fuse. So basically these fuses used to be used in olden times. Okay, long back we used to use these electric fuses, these type of electric fuses. Okay, nowadays this is the latest fuses and we don't call it fuse, we basically call it MCB. What is MCB? If I write its full form, that it is miniature circuit breaker. And we will not go in deep of its mechanism, but you just need to remember that nowadays we use this MCB. You also must have seen this MCB at your houses, but in the olden times we used to use these type of fuses. Now guys, let's talk about the purpose of electric fuse. Okay, so what happens in this electric fuse? There is a very small wire like this. Okay, now what is the work of this wire? Basically, this wire completes the circuit. Let's suppose in this line your current is coming in this circuit, lots of appliances are working, okay, on this current. Now what happens? Sometimes we observe the voltage fluctuation. The voltage fluctuation. Now because of the voltage fluctuation, our current also fluctuate, and because of this fluctuation, our appliances may get damaged. Okay, so to prevent this damage, what do? We use this fuse. What happens when the higher current is passed through this wire, then this wire burns, and if this wire burn, then the circuit will be disconnected. It means the circuit will not be completed, and if circuit is not completed, so the current cannot flow in this circuit. So this way we can save our appliances. I hope guys you get my point. So now let's talk about the material by which this fuse is made up of. So this is a wire, and this wire is made up of PB. We call it lead, and its symbol is PB, and tin. Okay, and we call it tin, and the symbol of tin is SN. So basically 67% tin is used, plus 67% lead is used, and 37% tin is used. Okay, so here this lead has very less melting point. This has very less melting point. So if you pass higher current, then the more current you provide, the high current you provide, the heat will also be produced higher, because our heat is directly proportional to this current. So if the current is higher, then our heat will also be higher. And if heat is high, then because it has less melting point, so it will melt and it will disconnect or break the circuit. So guys, in this slide, we will discuss this question. So what is this question? First of all, let me read it for you. So here, find out the resistance of a wire which length is 2 meter and area is 4 meter square. Resistivity of the wire is 2 ohm into meter. So this is the question which have been given. So let me write the solution of this question. So first of all, let's write down the information which have been given in this question. So we have been given length, that is 2 meter. We also have been given the area, which is 4 meter square. And we also have been given the resistivity, which is 2 ohm into meter. Okay. Now guys, you might be confused. What is this resistivity? So, okay, so you do not need to be confused. We understand this resistivity very deeply. So let me write down a formula here. We know that resistance is equals to the resistivity multiplied by length upon area. So this is the formula. So by this formula, if we put these values in this formula, then we can simply find out our answer. So what is the value of this resistivity? 2 multiplied by L, which is 2, and divide by this area, which is 4. So if you calculate it and if you solve this, then you will get 1 ohm. So the value of the resistance is 1 ohm. I hope guys you get your answer. Now let's move on to the next slide. So here in this slide, we will discuss this second question, and let's write down the solution of this question. So basically guys, in this question, let's write down what data we have been given. So we have been given the length, that is 2 meter. We also have been given the area, that is 4 meter square. And we also have been given the resistance of a wire, and that is 2 ohm. Okay, so let's read this question. Find out the resistivity of a wire which length is 2 meter and area is 4 meter square, and resistance of the wire is 2 ohm. So this question is similar to the previous questions. Why? Because in the previous questions, we apply this formula, rho L by A. So that time, we had been given the value of this rho, and also had been given the value of L, which is length, and area was also given. So we simply calculated resistance. But in this case, we have been given resistance, but we are asked resistivity. This resistance is given, but we are asked this resistivity. So we can calculate it simply. How can we do that? Let's suppose this is your resistivity, and if I cross multiply this here, this A here, and this L here, then it will give me R A upon L. It is as simple. Okay, so this is the formula of resistivity. Now, how can we calculate? We know that resistance is 2 ohm, area is 4 meter square, and length is 2. So I will cancel it 2 and it will give me 4. 4 is the resistivity. But will I write only 4? No, I will have to add ohm into meter. Ohm into meter. So this is the value of resistance. I hope guys you understand this point. I hope you understand this point. Now let's move on to another question. So here we are, this is question number 3rd. So in question number 3rd, what we have been asked, let's see that if 3 resistance, 2 ohm, 3 ohm and 4 ohm are connected in series. Okay, so find out its equivalent resistance. So here it is saying that our resistance are connected in series. Our resistance are connected in what? Series. So we know that whenever resistance are connected in series, then equivalent resistance can be found out by this formula, and that is R1 plus R2 plus R3. Okay, had it been 4 resistance, I would have been writing R4 as well. But because only 3 resistance are given, so that's why I wrote this formula only for 3 resistance. Okay, and you can also cut it short, and you can also remember that whenever resistance are connected in series, you simply, what do you have to do? You have to simply add these resistance and you will get the equivalent resistance. Okay, so let's write down whatever we have given. R1 is 2 ohm, R2 is 3 ohm, R3 is 4 ohm. So let me put these values in the formula. 2 plus 3 plus 4. And let's solve this. 4 plus 3, 7 plus 2, 9. So the equivalent resistance is 9 ohm. So I hope guys you understand this point. Now let's move on to the next question, and that is question number 4. And in this question, let's see what this question is asking to us. So if two resistance of 2 and 3 ohm are connected in parallel, find out its equivalent resistance. So guys, in this question, let me write down solution here. So in this question, they are asking us that the equivalent resistance we need to find out, but here in this case, the resistance are connected in parallel. You can see the resistance are connected in what? Parallel. So can I use this formula here? R is equals to R1 plus R2. No, I can't use this because this formula is for series connection. But here he is clearly mentioned that you can see that the resistance are connected in parallel. So what you have to do, you have to apply this formula. 1 upon R is equals to 1 upon R1 plus 1 upon R2. This will be our formula. So let me apply this. 1 upon R is equals to 1 upon R1. And what is the value of R1? R1 is 2 ohm. R1 is what? R1 is 2 ohm. And what is the value of R2? R2 is 3 ohm. Let me write it here. R2 is 3 ohm. And when I solve this, then I will get 5 upon 6. Okay. Now guys, what do I have to do? I have to simply inverse it to get my equivalent resistance. Okay, if I simply inverse this, then I will get the equivalent resistance. So this is a final answer. And also I have to write down its unit. Okay, it is very, very, very important. So this is our answer. I hope guys you understand this. Now let's move on to the next slide and let's talk about some other questions. So here we are. So here in question number 5, the SI unit of electrical resistance is what? So it is a very simple question, This question is just checking your knowledge, what we have seen. So basically, the SI unit of electrical resistance can be Kelvin. No, it can't be Kelvin. It can be volt. No, volt is unit of potential difference. Okay, yes, ohm is the right answer. Ohm is the unit of electrical resistance. Ampere is the unit of current. So it also cannot be the answer. But ohm is right answer. Now guys, let's talk about other question. Question number 6. Here it is asking the unit of power is what? Is it Siemens? Is it volt? Is it watt? Or is it Kelvin? So Siemens can be the answer. Volt, we know that it is unit of potential difference. Yes, of course, watt is the right answer in this case. And Kelvin cannot be the answer because it is unit of temperature. So here, the right answer is option number C. So I hope guys you understand this lecture, and I will see you in later lectures. Bye bye.